The scene begins with a group of Dall's porpoises racing through the water with remarkable purpose. Their target, a massive adult orca, the ocean's apex predator. What happens next defies conventional wisdom about marine animal behavior. Rather than fleeing in terror, the porpoises approach the killer whale with what can only be described as curiosity. They dart underneath her massive form, weaving around her with an almost choreographed precision. For several minutes, this underwater ballet continues until the porpoises, apparently losing interest, shift their attention to new participants in this aquatic theater. Their next targets are even more intriguing. A mother orca accompanied by her young calf. The moment the porpoises appear, the calf's behavior transforms completely. Energy surges through the young whale as it accelerates, attempting to match the porpoise's playful movements. The scene resembles nothing so much as a child trying to keep up with older kids at a playground. The calf looked like it was having a great time, observes Brittany Visona-Kelly, a whale biologist with Oceanwise, a non-profit conservation organization based in Vancouver, Canada. She captured this remarkable interaction using drone technology, providing researchers with an unprecedented window into these mysterious encounters. The mother orca, however, tells a different story. Her patience gradually erodes as the play session extends. Her growing frustration manifests in increasingly dramatic tail slaps against the water's surface, nature's equivalent of a parent calling their child in for dinner. Yet the porpoises remain remarkably unfazed by these displays, continuing their games for several more minutes before finally departing, leaving the orca family to continue their journey. This captivating encounter represents just one documented instance of a broader pattern that marine researchers are only beginning to understand. Throughout the coastal waters of British Columbia, similar scenes play out regularly between northern resident orcas, Dall's porpoises, and Pacific white-sided dolphins. The implications of these interactions extend far beyond mere curiosity. Researchers believe they may be witnessing the first known case of positive interspecies relationships involving killer whales, creatures that typically inspire fear rather than friendship in other marine animals. The mystery deepens when considering the stark reality of ocean life. Orcas reign as undisputed apex predators, capable of hunting everything from seals to great white sharks. Under normal circumstances, smaller cetaceans would maintain a respectful distance from such formidable predators. Yet here, porpoises and dolphins actively seek out these encounters. The stage for these unusual relationships spans a vast marine landscape. Northern resident killer whales inhabit waters stretching from the northern reaches of Vancouver Island up through the British Columbia coast into southeastern Alaska. This territory overlaps significantly with the ranges of both Dall's porpoises and Pacific white-sided dolphins, creating numerous opportunities for interaction. However, the northern residents don't rule their domain unopposed. The ocean here tells a more complex story of competing orca populations. Southern resident killer whales venture into parts of the northern resident southern range, while Big's killer whales and other transient groups patrol the entire coastline with different hunting strategies and social structures. All three types of killer whales are almost thought of as different species, Visona-Kelly explains, highlighting the significant behavioral and ecological differences between these orca populations. This distinction proves crucial to understanding why smaller cetaceans might choose to associate with one type while avoiding others. The groundbreaking research, published in Ecology and Evolution, provides the first systematic analysis of these intriguing relationships. Visona Kelly and her colleague Lance Barrett-Leonard meticulously analyzed 42 documented interactions captured by drone footage between 2018 and 2021 in Johnston Strait, the narrow waterway separating Vancouver Island from the British Columbia mainland. The data reveals a consistent pattern that challenges conventional understanding of marine predator-prey dynamics. In every documented case, the smaller cetaceans initiated contact with the Orcas, actively approaching rather than being pursued. The encounters often involved complex swimming formations, with dolphins, porpoises, and orcas moving together in coordinated patterns. Sometimes all three species participated simultaneously, creating underwater processions of remarkable diversity. Perhaps most fascinating were the extended play sessions between the smaller cetaceans and orca calves. While most interactions lasted only a few minutes, some stretched beyond an hour, suggesting genuine social engagement rather than brief encounters of convenience. The researchers have developed several theories to explain these unprecedented relationships, with the most compelling involving sophisticated survival strategies. The leading hypothesis suggests that dolphins and porpoises use northern resident orcas as living shields against more dangerous predators. Big's killer whales, unlike their fish-eating northern cousins, hunt marine mammals. Their diet includes precisely the species that seem drawn to northern residents: Dall's porpoises and Pacific white-sided dolphins. This creates a deadly game of oceanic cat and mouse, where the smaller species must constantly balance feeding, breeding, and survival needs against the threat of predation. The northern residents offer an elegant solution to this problem. These orcas typically travel in larger, more cohesive groups than Big's whales, making them formidable even to other orcas. Big's killer whales, evolved for stealth and ambush hunting, generally avoid confrontations with the more social northern residents. The acoustic environment provides another layer of protection. Northern residents are notably vocal, maintaining constant communication through complex vocalizations as they hunt salmon cooperatively. Big's whales, by contrast, rely on silence for successful mammal hunting, remaining largely quiet to avoid alerting their prey. This acoustic difference might serve as an early warning system for dolphins and porpoises. By learning to distinguish between the vocalizations of fish-eating and mammal-eating orcas, these smaller cetaceans could effectively identify safe versus dangerous encounters from considerable distances. While the protection hypothesis offers compelling logic, researchers acknowledge other possible explanations for these unusual alliances. One intriguing possibility involves intelligence gathering. The smaller cetaceans might approach northern residents to study orca behavior, morphology, and capabilities up close. This know-your-enemy strategy could provide crucial survival advantages. By familiarizing themselves with orca movements, hunting patterns, and physical capabilities in a safe context, dolphins and porpoises might better prepare for potentially fatal encounters with predatory Big's whales. The learning opportunity extends beyond individual survival to species-level adaptation. Young dolphins and porpoises observing these interactions might acquire crucial knowledge about distinguishing between dangerous and benign orca populations, potentially saving their lives in future encounters. These discoveries force marine biologists to reconsider fundamental assumptions about ocean ecosystems. The traditional view of apex predators as solitary actors at the top of food chains gives way to a more nuanced understanding of complex interspecies relationships involving cooperation, protection, and mutual benefit. The research also highlights the sophisticated cognitive abilities of marine mammals. The behavior patterns observed suggest advanced decision-making capabilities, acoustic discrimination skills, and social intelligence that rivals the most complex terrestrial animal relationships. Furthermore, these findings demonstrate the importance of long-term observational studies in marine environments. Without drone technology and persistent monitoring, these subtle but significant relationships might have remained hidden beneath the waves, unknown to science. Understanding these relationships carries important implications for marine conservation efforts. The interconnected nature of these species suggests that protecting one population directly benefits others. Conservation strategies focusing solely on individual species might miss crucial ecosystem dynamics that determine survival success. The research also underscores the complexity of marine ecosystems in British Columbia waters. Any environmental changes affecting one orca population could cascade through the entire community, influencing the behavior and survival of multiple cetacean species. As research continues, scientists hope to expand their understanding of these remarkable relationships. Future studies might investigate whether similar patterns exist in other ocean regions, whether these alliances influence feeding success or reproductive outcomes, and how environmental changes might affect these delicate interspecies bonds. The discovery of positive relationships between apex predators and their potential prey represents more than scientific curiosity. It reveals the ocean as a place of unexpected cooperation and complex social dynamics. In the waters off British Columbia, killer whales serve not just as fearsome predators, but as protectors and playmates in an underwater community more sophisticated than previously imagined. This research reminds us that the ocean holds countless secrets yet to be discovered. Each new revelation about marine life complexity reinforces the critical importance of protecting these remarkable ecosystems and the extraordinary creatures that call them home. In the dance between porpoises, dolphins, and killer whales, we glimpse an ocean far more intricate and collaborative than we ever dared to imagine.